Hey guys, in this lesson we're going to practice using a network load balancer with a static IP, so it will be an elastic IP address in each of two different availability zones, and we're going to see how we can use whitelisting. So we're going to allow only access to those specific static IP addresses. Essentially our solution will look much like this, and what we'll do is we'll use a EC2 instance in terms of this testing client here. And that testing client is going to have a security group, and the outbound rules of that security group are only going to allow HTTP port 80 to the specific elastic IPs of our network load balancer across two availability zones. And we'll have one target group with a couple of instances. So let's head over to AWS. The first thing I'm going to do is I'm going to use the launch template, but I just want to show you what the settings are. We created this in a previous lesson. Just in case you don't have it, let's go ahead and click on modify so we can see what the settings are. So I've got the Amazon Linux 2023 AMI, T2 micro, I'm not including a key pair, and I've got the security group called web server, and that will allow port 80 inbound. In addition, at the bottom here in advanced settings, we have the user data, which comes from a file in the course download. So that user data is in the code, auto-scaling in ELB, and then user data az.md file. So that's all good. I'll cancel out of there. Let's go and create an auto-scaling group. I'm going to create my ASG across two different availability zones. I'll call this ASG1, choose request routing, and then next. And I'm going to select US East 1A and 1B. Then I'm going to click on next. We're not attaching a load balancer. We're going to click on next again, set the desired minimum and maximum to 2, skip to review, and then simply create the auto scaling group. So that will launch our two instances across two availability zones. Next, we're going to go to elastic IPs. And in elastic IP addresses, we're going to allocate an elastic IP address and just choose the option to allocate. And then we're going to do the same thing a second time, allocate. And if we clear this filter, we've now got two elastic IP addresses. So those are ready for our load balancer. Now let's go to load balancers, create a load balancer, and we're going to choose network load balancer. I'll call it NLB1. It will be internet facing. It will be in the default VPC. And we're going to select two availability zones, US East 1A and US East 1B. This time we have this option here to select an IPv4 address. By default it will be assigned by AWS, but I'm going to choose to use an elastic IP address. I'll do the same again in this second subnet, and it's tried to allocate the same one, so let's make sure we change that so we have a unique IP per availability zone. So now these are going to be static IP addresses for the load balancer in those subnets. Now what we need to do is create a new target group that's going to open up a new window, and I'll call this one NLB-TG1. The protocol is TCP in this case, not HTTP. Leave the default there, and let's click on next, and we'll allocate these two instances. Let's include as pending below. Then we can create our target group. So that's done. Let's go back to load balancers, click on refresh, and now we can select the target group. And then let's scroll down to the bottom and create the network load balancer. So that's being created, and while that's happening, we're going to launch another instance which is going to be used for performing the tests. So I'll call this one test client so I can identify it easily. It will be Linux 2023 AMI, T2 micro. We don't need a key pair, and I'm just going to leave the default security settings there and just launch the instance. However, I am going to create another security group. So let's go to security groups, create security group, and I'm going to call this one Whitelist. And then let's put that into the description. It will be in the default VPC. To connect to the instance, we'll need SSH. So we're going to have SSH from anywhere. And then I'm going to delete the outbound rules for now. And let's just create that security group. Coming back to instances, I want to assign that to the new instance I just launched, my test client. So I can go to actions and then security, change security groups. We'll remove the one from the launch wizard, and we'll select the whitelist security group and then add security group and save. So now we only have the inbound rule. So we just want to see what happens when we try to connect to the load balancer. But we need to make sure the load balancer is ready. So let's go to target groups, select our target group and go to targets. And it's still initial at this point, so we need to wait a few minutes until both of our instances are healthy. Now I have two registered targets that are in a healthy status. So I'm going to head back to load balancers, select my load balancer, get the DNS name, and we should find that this is now working. So there we go. We have our instance responding using the DNS name of the load balancer. So let's test out the whitelisting. We're going to go up to instances, choose our test client, click on connect, and then connect again for instance connect. And I'm going to try to access the load balancer DNS name using the curl utility. And I've pressed enter. It's not responding, it's timing out, and that's expected because, of course, the security group that we're using here does not have any outbound rules. So what we need to do now is add the specific IP addresses of our load balancer. So I'm going to go to outbound rules for my whitelist security group. In a separate tab, let's open the Elastic IPs. So these are my IP addresses. Let's copy one of them, come back, add a rule, custom TCP, port 80, and I'm going to put in the IP and then /32. /32 means an exact match. Add that one in. Let's do the same for the other one. So click on add, and it's going to be custom TCP, port 80. Let's copy the other IP, so the second Elastic IP address, and let's put that in, and again /32, and save those rules. So now we have the two rules. It's resolved them to HTTP, TCP port 80, and we're only allowing access to these specific IP addresses. This is an example of whitelisting where we have a firewall and we're only allowing the connection to go to two specific IP addresses. So we need to make sure that these IP addresses never change. And that's what you get with the network load balancer. Because it uses elastic IPs, the IPs associated with the nodes do not change. So let's go back to Instance Connect. I'll just kill that command, try again. And now, of course, I get a response. So now it's load balancing between the different availability zones. So that's an example of using an NLB with static IP addresses and then whitelisting them in a firewall, in this case in a security group. Okay, so we finished with this lab. Let's come down and clean things up. So I'm going to delete the load balancer. I'm going to go to auto scaling groups and delete my ASG. And then I need to independently terminate the test client. And lastly, once the load balancer is no longer using these elastic IPs, we will be able to release them. We can try that now, but it's telling me that we can't. So just wait until the load balancer is fully deleted. You do need to release your elastic IPs because you do get charged for elastic IPs, but only when you're not using them.